Yeah, also because since our channel is no one knows it basically until I give the link of the YouTube video. No one is looking basically. Okay.
Okay, we are live.
Good.
So,
Okay,
let's
so
start.
how many people we have? Yeah, I guess we can wait a bit. 13 people accept us. In the meantime, I will be tweeting the YouTube link so people that are not registered can also join.
Yeah, just let me know when I can start.
Yeah. How are things in Barcelona?
Good. Now, like less windy. Nice blue sky. I moved, so now, Mate, you won't have the pleasure to see me in this timely. So I move house, so that's good.
It's done now.
Yeah, it's done. And it's really nice weather outside, and like looking at the water, and like I want to go have a walk by the beach.
The other panelists, how were the sessions that the rooms you were in? People were interested?
Yes. Yeah, almost everyone stayed till the end.
Good.
Plan, sort of.
Yeah, it was good.
Yeah, it was great. Very interesting chat.
Until you came in and had to kick us all out.
Yeah.
I wanted Simona to kick all of you out so you wouldn't.
But you are the boss.
But I
I
made you
refuse to execute Order 66.
Yeah, we somehow came up with lots of really interesting but quite complicated projects. So
for a moment I entered your room and I saw that you had an actual piece of paper with a lot of things writing on it.
Chantal got out her notepad.
Time to be organized.
Yeah, it really helped. So
Okay, so I guess that we can slowly start. So tonight this, and it's not the last session, but the last session, it's not the serious one. This is the session with Paolo Rodriguez from Qmenta. He will talk a bit about the Qmenta platforms and about why we all need containers, but some of us still pretend that we don't. And it's a good chance to see if any of your projects can benefit from running on cloud, and if you want to give reproducibility / open workflows taste at your project. And I will start recording. So Paolo, whenever you want, you can start.
Yeah, okay. So, you see my screen, right?
Yeah.
So, yeah, thank you so much, Matteo, for the introduction and invitation to to add our little grain of salt to the challenge and to the BrainHack, in fact. And as you well said, now there's today I'm gonna be speaking about how we are using Docker and containers, and like how that is attached or parts or one of the pieces of what we call the Qmenta platform. So like this cloud infrastructure to really help in scaling and optimizing and distributing imaging workflows. So like, I'm sure that everybody in the hack is super excited in running and contributing to the different projects, but there's also challenges, and that's what I'll be talking today, how we are tackling some of these things. Well, I'm not in the Atlantic Ocean. I'm calling from Barcelona, so it's like from the Mediterranean Sea, but it's near enough. So that's also okay. So I'm going to be talking a little bit about, there's lots of hype and there's lots of activity in AI and medical imaging AI, especially in neuro as well, CNS, but other medical applications. But there are some challenges, as we all know, and a part of that is not only related to training and building your algorithms or computational tools, but then also how to make them easy to use, because in the end, everything that we are doing and everybody here is doing is like figuring out how to make a best model, or how to make or how to create the most reproducible method for cryptography or for something else. But then that's great, and you can share the code on GitHub and publish that, but then for somebody to use it, there's a bunch of challenges. So that's why we use Docker as a way to make all this process easier. And then some examples, or basically some links and some information on how you can share your code through this way that we're helping also, like with different challenges out there and BrainHack. And then in the end, like I'm not gonna take lots of time, so then there's plenty of time to talk about ideas or different projects and how we can help with the cloud infrastructure and Docker as well, how it can help maybe some of the projects. Yeah, so coming back to the topic, right, like in building computational tools, or AI to call it, like in broad names, like a way to look at it, right, is there's typically a use case or some question, but there's a lot of effort in this initial part in preparing the data, accessing the data, preparing it, anonymizing it, labeling it, curating, is it good quality or not. Then you take those images, that data, and actually build or train your model, and repeat and repeat and repeat. And in all this process, there's lots of issues dealing with data, managing it in a way that, by the way, because it's all healthcare, is also to be compliant, right? That has to be anonymized, or GDPR in Europe or HIPAA in US. There's lots of challenges also there. And there's a lot of time and effort and energy, in a way, spent in dealing with data engineering and preparing data for the different models, or the different machine learning, or the different techniques or tools. Then if you take that further, you have a great algorithm, you potentially want for it to be used in clinical care, right? So there's like the FDA getting regulatory approval, but even not considering the FDA or like the clinical use or the clinical usage of some of these tools, even just you build a model, you build a tool, and then you want somebody else to use it, right? There's issues, because the users in many of these cases are clinicians, are not like so much engineering savvy or tech savvy kind of profiles, and that which is totally fine. But you want that your tools are distributed, and actually the great algorithm that you created is easily used by psychologists or clinicians, or the different like clinical partners in the projects, in the studies. And there's a big challenge there as well, that is how to make that accessible and easy to use by these kind of profiles, right? Like in almost like embedded, if you will, in their workflow, how to make this code and these tools interoperable. And there was like this nice phrase, or this nice quote from this guy from Google, that there's a sure, one thing is like you're making all the effort in and proud to create an algorithm that is now super important, and it's to have it right, to have the best results. But besides that, also is like as critically important that algorithm is, that this fantastic tool is validated, but is embedded. It's part of the radiologist or the clinician's workflow. So like how to make, there's one challenge in creating and building the tool, technical and data challenges, but it is like how to make that tool available and to be run or used by the end users in this case, right? So the way that we, let's call it democratizing, it's like the way that we use is like when we, suffering or having suffered also like these issues, we basically, it's very easy the way to use the platform. So like this cloud platform, Documenta platform, and Docker. So on one side, the developers can use Docker and easily push their code into like a Docker hub, into a register. So like they share the code into these executable containers. That becomes available as an option, like kind of a drop-down list of potential tools that any user can run. So like they attach they plug in a way, developers can plug in the tool into the platform, and then the end user might be the developers, might be the brain hackers, might be a clinician. They simply use the web interface and then apply that latest algorithm that was just published. They can run that algorithm just with a click of a button of an option, and apply that, run that into the data that they just uploaded. And everything gets scaled automatically in the cloud. So all this effort of technical moving data around and executing Dockers and all these things, like it gets pretty much straightforward, almost like off the shelf kind of thing. And so I'm gonna come back to that, like how everything fits together. But maybe because part of the audience probably heard about Docker, so quick intro, like what is Docker? Like what's the difference with the typical way of doing things? Like starting with the typical way of building or developing, like you have your operating system, right? That there's you can code and you can write your code and run things in your laptop, in your computer. But the challenge comes when then you wanna make that code available or make that tool, that thing that computes some results, to share that. The way that you do it is share your code. You publish it on GitHub, and then somebody on the other side of the world needs to download that code and try to figure it out, how it works, how to make it work, how to run your Python script or your Bash or your MATLAB, what are the parameters, and then maybe also your system is different or different version, or you have different libraries in your own system, and there's like lots of headache normally in getting all these environments that you need to run your algorithm to make it. So all the libraries, you need to also like take lots of care about that and waste energy in doing that. But the point here with the operating system, like with like a single machine, is like you have different applications that share a common set of libraries that you have installed in your computer, and that has it's maybe effective in some sense, but then it becomes very difficult to share and to collaborate with that respect. I kind of skipped a step. There's also like virtual machines. So like you're not binded by your hardware, but you can have virtual machines, even locally, but also like in a cloud environment, like Google Cloud Platform or Amazon Web Services. So in a way, you have a snapshot of so virtual machine, right? Like your operating system, like you have that virtual computer in the cloud that you can access. So you can have different versions or have like different instances of different virtual machines already, like with the pre-installed libraries, or you set up your development environment, execution environment. It has some advantages. You're not binded by the hardware. You can replicate that easily. So you can it's a step further in running like studies, where we would run, imagine different free surfers. So you could scale, you can start different virtual machines and and do it kind of launch this free surfer in the different virtual machines. So it's like easier to scale, but still you have the issues with sharing the code. And then containers, where you come to containers, like you probably, I'm sure you're familiar with Docker or LXD or other Singularity and other systems, where basically it's like you have like the containers, like this smaller kind of image. So a set of basically is almost like data, is like a series of files or a set of files, let's say, that inside it runs on your computer in different systems, but like inside it, you can add like different layers, like you can configure, have smaller, like imagine like little virtual machines that you add the libraries and the code and different things. So like your applications, and then you can really have an isolated, like this container, like basically like a little image, so that you have that you can move around easily. It's a much more flexible than other systems. Not as flexible as virtual machines, for some security aspects, but figure that out. But it's very easy to ensure great performance, isolation. It's easy to maintain. You can have versions. You can share like some files, the Docker files, like to create, to launch this kind of like your version of a computer and install everything inside. So it's a way to have versions almost like on a virtual machine, and in a way also it works very similar like GitHub, like with this kind of commands to build your image, your Docker image, to pull and push from a register where these images are stored, and then you can also just fetch one and run, like fetch the image with FreeSurfer version 5.3. Just fetch it, it gets into your computer, and then you run it, and you're sure that that version is nobody touched it. It has exactly the environment that you defined before. So in a way, with the Docker and with containers, is a way to have almost like code or executable code handle as data that you can also store and move around. So instead of, it's an opportunity to bring the code to the data instead of the other way around, right? So there's several advantages there, like you can version and share these executable tools. These executable tools also, like the other interesting aspect of containers, is that there's these the different execution environments or container managers that basically, what, like on the bottom of the image, you can have, for instance, a container that has for morphology, so that has installed ants, that is already compiled, that has a specific version, some certain libraries, and other DICOM to Nifty and other kind of things there. You can have another container that has MRTrix pipeline, configure with a Python script inside that gets an input and has a bunch of things, and using MRTrix, and then it creates cryptography, for instance. So you can have these two containers, and in one single virtual machine, you can just tell the virtual machine, okay, start running ants container, and also in parallel run this other container with MRTrix and these other things. So these environments like Kubernetes and another execution like frameworks makes it also very easy that it can scale. So you could say, I want to run, like with Kubernetes, just run 100 containers like MRTrix and with all these inputs, and then they would scale automatically. So you don't need to worry about provisioning or turning on and off machines or virtual machines to accommodate your needs of processing, like for the different studies or different images. So that's these execution environments. And the thing that then we have associated with this is also we created then the platform, the Commander platform, that combines a data management system, so like a database and like storage. So then we can receive, users can easily store and manage DICOMs and hundreds and thousands of records of patients or subjects that have multiple files and multiple DICOMs inside. So to easily manage that, but in parallel, then there's also this engine that manages and runs and executes the tools. So then it becomes very easy that combining both, you can just have in your project, say 100 diffusion subjects, like 100 subjects with DTI data, for instance. It's stored there, and then you could have an execution like a tool with the SDK. So like you can have in a Docker one cryptography algorithm, you would plug in another cryptography algorithm, and then you can just say to the platform, okay, to these 100 data sets that you have there, run cryptography algorithm 1 and run cryptography algorithm 2. And in a couple of hours, everything will be calculated, because the execution engine will then just get the respective files, iterate through everything, scheduling the different pods and different Kubernetes virtual machines, and everything will be calculated. When they are done, it will store back the results of these algorithms. So like it takes out all this complexity of scheduling and dealing with data, moving data around, and having code and GitHub and versions and parameters, like makes it all, connects everything. So then you can really get simple workflow from receiving data, from getting data, like even that comes from Apax or from wherever, to have that, then start launching a workflow that would, for instance, convert that income to Nifty, launch then another Docker that would do the ants cortical segmentation, and would do then a matrix, will do tractography, and then combine the results of both and do a connectome. So you could easily start doing these things, and everything is also scheduled automatically behind the scenes. So how everything fits together. So what I meant like with the platform and the SDK, so just give like not even a demo, just some screenshots. Like the platform is just accessed through the web. Everybody can just create an account. Like what you see here is the part of data management. So like here, every row here corresponds to a subject. Like this is, if I'm not wrong, like the Oasis data set. So you have here subject 1, 2, and also even have longitudinal data with the sessions, like different time points. Associated with each one of these subjects, if you would like right click and show the files, you would see inside the different DICOM files or NIFTs are the different files that are associated with this subject and time points. You can also have metadata, so like things that normally you would capture from ECRFs or from like RedCap or other things, like normally things that you keep track of on an Excel, could also easily associate to the images. And then, so that's for the easy aggregation. There's a couple of things also to make sure that the data is really anonymized when it's stored, that it checks also like if the protocol, the imaging protocol is respected or not. So if the study is supposed to have, can define a T1 with certain resolution, diffusion with the 80 gradient directions, and a couple of other things, it can check automatically when the data arrives, if all of that is correct, or if not, immediately labels the quality as not pass, something is wrong with it. So then ensuring that the quality is there, so like the data is complete and correct. And then you could easily select one subject or all of them, 25, 87, doesn't really matter. And then select from this drop-down list, like what tool or which workflow you want to apply. So in the end, which Docker you want to run and apply to the data. In this case, like that's an example for CNX 5, but the Docker is version 2.4. So then you can also modify that. I'll go quickly with that because there's documentation. Now I'll point to you. So like what happens behind the scenes, so like from the user interface where you select this patient 1, I want to run a tool A. What happens behind the scenes is like it will fetch the respective Docker that was selected by the tool, by the user. It will fetch from the registry, and it will then launch a very basic Python script that is the entry point for the Docker, like when it's executed. And that Python script is really like minimally just like this. It will start in this run method. The first part is just a way to tell it like, okay, download to this Docker, to wherever this virtual machine is run, where the Docker is executed. Like it will go here and say, give me the files that the user selected. With this input part, you don't need to worry about giving the files that have a specific name, but just like certain conditions, like give me the file that is labeled as T1. Then you launch your code, you launch your MATLAB or your Python or whatever, a matrix or a preserve, like you whatever you put inside the Docker. And then when it's done, you just say, okay, now upload these and these and these file as my results. And then behind the scenes, the platform will make sure that the files are sent to here to execute, and then they are stored in another bucket, and everything is traced. So you can have multiple versions also of running your tools, applying these algorithms. So everything gets really nicely tracked and traced. I'm gonna bypass this. So like there's a couple of functionalities, like what I said, like you don't need to worry about file names when you're attaching the inputs to the inputs of the Docker. But really what's more important is like these tags or modalities. I want a T1, I want a T2, I want T1 with a post contrast tag, or a diffusion or a DTI or hardy. So like it helps to make sure that to avoid errors in fitting the inputs to the tools. And some neat things, so like you can choose which files to upload, so to store then as results of the analysis. There's also metadata, so the tool imagine like CNX could also add automatically to that Excel or to that table that I showed you before, can also add the measurements automatically to that table. So then you can in the end just export as a CSV, or even with Jupyter notebooks, like interact and then run your group level analysis or your favorite like R libs. And a couple of neat things like for context to inform the user what's the progress of the how far it is. You can set progress like visually, that is displayed like it's 0%, 10, 20, 50% error messages, informations, like kind of neat things to keep the user informed what's happening, which is also very important. Yeah, then to commit and push. So back here, so with the SDK and the platform, it's very easy for developers to push and to publish their code, to distribute, to democratize in a way their computational tools. They are plugged into the platform, so then it's also very easy to run those tools into lots of data sets as part of a study. And then it makes it also very easy that then you can quickly download and effectively download like all the metrics, all the measurements for your study in one single like CSV, for instance. So then you can do the rest of the study. So it's very easy to get results, visualizing the web, get PDFs, so many cool things that helps in executing studies. Yeah, here I'll leave it for a bit, but like the slides will be shared in another place. So there's different like useful links, especially like for the Iron Track, for instance. There was a challenge that we were also helping. There's like a concrete example, like how to build a Docker for, in this case was some tractography code with IPy, I believe. So basically an example of how to use the SDK. There's more documentation about different methods here, about the library as well, about the API, some more examples. And part of the BrainHack, there's different challenges. So I would also like to just point out to this link, documenta.com/Brain Innovation Hub. So that's the invitation link for a Slack channel where we are there. If there's any questions, doubts, ideas on the platform, or if you'd like to to try it out or test it out, or if there's anything related to the SDK and to the BrainHack, that's a place where you can find us and talk with us. And yeah, and that's what I wanted to tell you about, like briefly, and open for questions. Like I just pasted here the latest list I saw from the projects, and if there's any ideas or questions on how to how a cloud environment like this and the SDK could be useful to help with the hackers and with the different projects, maybe like the reproducibility one. So open to the ideas and how we can help you in getting the projects further.
Thank you, Paolo. And since this has been quite a hackathon in the hacker style, you are actually missing one that was put there this morning, so it's okay.
Okay. I just did it like, I know. So
no, it's okay, even because even the mine that it's the most recent one was last night. So chapeau for that. Thank you.
Yeah.
So anyone has questions, both from the other panelists and the attendees? For the attendees, of course, feel free to both use the chat and the Q&A, and we can address any question. Since I don't see any question yet, I can start. So what I wanted to ask you is if a random user that knows about Documenta wants to try out the tool that it's released there on the platform, so the Docker file, the Docker is already ready and things like that. Is there like an amount of execution time that it's for trial or something like that?
So Yes and no. So like anybody can just go to the website like documenta.com, and like there's a sign in like button, so you can just create an account and to try it out. So like what we have is like the default, there's like limit, so then there's nobody that pretends to be a good person and then tries to hack and like just flow overflow the system. So like we have by default, if I'm not wrong, like 10 executions. So it's not really on time, on compute time, it's just like running 10 times an algorithm. But that's just like the default like quota. But we are always open for just have a chat, and we can just change that and set like different limits. So it's really like it's been there, so like did my PhD in Eindhoven and like being in this field. So like it's we're very open to collaborations and like how to helps to speed up and support research R&D, because I think we believe that by moving that forward, that's how we then you accelerate bringing these great algorithms to clinical care, to clinical trials, especially, and then clinical care. And that's where actually, as a company, that's where the money is, right? So like we are, there's no limits on time, mainly on the executions, but we're flexible and we have different ways to collaborate.
So one can potentially concatenate 100 subjects to run on free
Yes,
surf.
yes, exactly.
Everyone heard. Let's go and run 100
we do have,
subjects.
like we monitor, so but they creative ideas. So we all do these kind of things.
I see a raised hand from Marco.
I don't
Yes,
see that.
hi. Yeah, hi, Paolo. Thanks for the great talk. I'm curious to know if the Documenta platform could be advantageous for federated learning. If the field is moving towards that direction, especially because more and more algorithms are converted into deep learning versions.
Mm-hmm.
And it's essential, you cannot have a model that generalizes across data set. So the best way to do that is federated learning.
Mm-hmm.
So from your talk, I understand Documenta deploy the model and just apply it. Is there a way to, get maybe my model to be trained on locally on the data set, and then you can send back to me the updated weights so that I can use your platform in a federated way?
Yeah.
Or are you thinking of going in that direction?
So. Yeah. Yes, pretty much. So it's so there's, let's say, 2 or 3 parts of that. So one is that there's so we use Docker as a way to package these tools, and we also like create our own algorithms, like also like deep learning, so like training it and then deploy the weights and be an executable tool. The thing I didn't mention like in the details is like, yes, it's a cloud or a cloud first system, right? So like it's hosted in the cloud, like in different environments. But also that means that we are already, in a way, let's call it federated, in the sense that we are already hosting data and the execution in different locations. So like there's like a consortium, for instance, on MS, that there's multiple countries in Europe. Actually, the coordinator is in San Francisco, and one of the partners is in Germany. So like that data from that site stays in a data center in Germany, and it's run. So the Docker is actually run in a virtual machine, in a data center in Germany. Like the interface doesn't look like it's all unified, but effectively it respects the data like jurisdiction. For the part of like more like the next level of federated is something that we're working on, and actually like with some collaborations where it's even more like with graph databases, for instance, like just today actually we're talking about that. So like how to bring these Dockers or this training into the sites, right? Train it and then bring back the model, so then it can go to another place. So it's something that we're working on, and I'm very happy to continue that discussion, because it's something that we are actively looking at and improving. Because as you well know, and everybody knows, like AI is nothing without good data and variability of data and more data and volume, but also different kinds, right? So it's very important, and then it enters all the regulations, jurisdictions, and GDPR and other topics. So it's very important that the future is going towards there.
Yeah, thanks. Yeah, I think the real power of a platform like the one you have built is indeed in this direction, is one of the best way you can exploit it, especially to make our model more.
Yeah, and it's something that is a next step, and we have like great foundations. Also, like what I mentioned before, that is to be embedded or in a way integrated in workflows, right? Because then, for instance, we have like some applications that makes it easy to get for hospital sites to push DICOM data from their PACS or PACS compliant software. So then that gets anonymized, gets routed to the platform, checks the keyway, launch the algorithms, outputs DICOMs, and then that can be fetched back and put back into the PACS, back to the site. So this kind of interoperable in and out of data, that's fundamental to then train new algorithms, and then when they are trained or that version is trained, then that can be used by somebody else. So that's the next step.
Okay, people ask questions because I can keep asking questions for a long time. So I don't know if it would be fun for all of you. So my next one is, during the Iron Track challenges, some people have updated some workflows on the platforms. Apart from that, do you have you started like some way to recruit people to share their containers also there, so they would be available for anyone, or it's something that it's still in kind of an experimental phase?
It's something that we're scaling more, like putting more focus there this year. So like besides the Iron Track, there's also the Memento challenge, Vanderbilt and others. BrainHack is another opportunity and something that we want to do and more and more this year to as a general idea, and be hosting a new webinar in March, right? So where like also like we'll be looking for ideas and projects and challenges that we can expand and have a way to people to create new tools. Oh, sorry, there's somebody's knocking at the door. So yeah, that definitely. And there's with these challenges and like this kind of campaigns, let's say, like with challenges, hacks, that we're going to be more and more supporting. And besides like collaborations with centers and universities, where it's like concrete tools that somebody's developing and then want to distribute, and maybe for some clinical study or some trial. Yeah, sorry about this. There's the joys of working from home. The kid is coming, so, and the door is locked. But yeah.
Okay, so anyone else from the project leaders, thoughts, curiosities about how things can move forward? Not necessarily in these few days. If you Marco again.
Well, I keep going as well at this point. Now, I was just curious to know, so you have different models in your platform. So if I'm a clinician acquired some data, I can just use your platform to process it, right?
Mm-hmm.
But is there any control on which model I use on the data, or it's up to me?
Yeah.
So for instance, I use DTI with b-value 5,000, and that doesn't make sense. So is it, or I fit a kurtosis model with b-value up to 6,000? Again, doesn't make sense. Is that up to the user, or are you planning also to work with the model developer to put some constraints or guidelines on how to use?
Yeah, basically a bit of both, but essentially like the developer, whoever created the tool, there's a couple of things that you can also define. That is to define what are your inputs. So like the inputs in the sense like, I need a T1 and a T2 and a diffusion image with at least 50 directions. Okay, you can define that. You can define also how the results can be visualized, for instance, or how do you create a PDF report. So like there's a couple of things that is kind of on the power or domain of the developer of the tool. Because then what the platform does is like when a user selects a data set and says, I want to execute this tool, it will check if there's a match. So if it finds if in the input container there's actually, or if in the input bucket, so like in the input data, there is a T1 and a T2, but there's no diffusion, for instance, it will say like, hey, I cannot run this because there's diffusion missing. So there's like,
but if I provide a diffusion with only 3 directions, does it warn me?
It can, yeah. So like
the results is not.
Yeah.
Okay, depends how you.
Yeah, there's like tags, there's modalities and tags, and also you can use like DICOM tags and other things to ensure that. And even before, so like when data arrives to the project, to the study, you can also like, there's a protocol adherence, so like something that will check if all those parameters are correct. So then you already, even before you try to run a tool, it will already tell you like, the QC, the quality is not didn't pass because there's something missing or incorrect from what was expected. So there's different control points to avoid those kind of things from a user.
Yeah, I like it, because there is a control on the quality of the data, on the quality of the output, but it seems you also allow to have a control on the actual applicability of a model, which sometimes is overlooked.
Yeah.
Great.
Can you just give me 1 minute? Sorry.
Yeah, sure. I mean, we are all working from home, so it's normal that you are on a meeting and then someone really needs to get you at the door, right?
I have a question, but my raise hand button doesn't seem to work. I don't know if anyone has that same problem.
I'm not sure. I didn't raise an hand in a while, but can you see my hand?
Yeah.
Yeah. Okay.
Okay, I'm back.
Mine doesn't work as well, Chantal, so don't feel.
Oh, really?
I don't know. Yeah.
Okay, so Paolo, Chantal was saying that she had a question, but she couldn't raise her hand, so now here she is.
I was just wondering about these GDPR guidelines and the opportunity to pool data with your platform, like what your experience is with that. As we had these discussions multiple times, but it's a bit questionable whether a brain scan can really be anonymized, and if you ever experience problems with that.
Sometimes it's a topic about if the brain images are actually identifiable or not, but we really just had one case, and actually in US, where there's like the requirement to actually deface the images. So not so much about the gyri and the aspect or the look, the morphology of the brain, but just the face in the images. So it's something that we solve that, or we mitigate that risk of like the private information or health information, not only by removing or stripping all the DICOM headers, right, like patient information and other things, so like automatically, even before uploads, so like even before it leaves the firewall of a hospital, but it can also like deface the images, so then there's less risk of identification. And not in EU, but in US, actually for kind of other reasons, but that was some concerns with some major hospitals in US, just like the ultimate discussion, right? Like, can you identify somebody technically? Yes, but then because it's reasonable technical efforts to do that, that's where it enters like certain terminology in GDPR and HIPAA. So like we handle it by especially by stripping out the DICOM headers and other things, and if necessary can also like deface the images, and that's more really great efforts in ensuring the PHI for GDPR and for different multi-sites, European-wide consortiums, and even collaborations with the US as well. So there's the discussion, but sometimes a bit more ultimate going all the way to the.
Yeah, so data pooling is also something that that the platform provides if the users agree to share data, or
yeah, exactly. Okay, data pooling, yeah, or data lakes, yeah. So that we have also already available if somebody could use like different like open data sets and different initiatives out there that are sharing data. Like there's different licenses, but like we continue that license. And if somebody wants to share or make some pool of data available to others, that's also like totally really want to help with that, because that's how we were doing, for instance, for COVID. Now, it's not the brain, but like for COVID, we're like helping to centralize and collect different data sets out there. So then like developers could have access to a wider pool of imaging data. So yeah, definitely yes.
No, I'm not sure on which point I want to follow up, because both Marcos and Chantal's points had interesting things. So let's go with the previous point, Marcos' points. So basically, when someone needs to introduce these reasonable limitations in the workflow, so like the examples that Marco made, it's is it on the developer, on the platform, or on the user? Well, of course not on the user, because the user won't know that there is a limitation, but is it then on the developer? And if it's so, should it make sense to like write some guidelines in this sense?
It's essentially on the developer. So like so the tool, so the Docker, like the executing part, the code fetches, just says download or give me whatever you have that is T1. So like it at that point when it executes the Docker, so when it starts that Python code, you already come with a chosen subjects and with images that were uploaded. But when the developer is building the tool and then integrating, so like registering it in a way in the platform, like you define the name, what's the Docker repository, credentials, what's the entry point, like what's the first script that it will start, and also you define what are the input parameters, right? So like, and that's like, there's like, we have the documentation, there's like a little kind of language, or not a language, but like a way to define that my expected input is this and that with these characteristics. So in that what's used when the user, on the side of the user, he shows a data set and then says I want to apply this Docker tool, it will check that if what is labeled in the platform as like the images that are available, if they match what the tool is requiring. So like it's up to the developer, following certain guidelines and the documentation, like the certain characteristics that we have defined. And then so that's part of the whole kind of imaging workflow, where part of when we also have when new data is uploaded to a project, there's the first thing that actually happens is like it launches another Docker, right? And another execution piece that actually will go through all these, DICOMs or what was uploaded and anonymizes it or checks if it's anonymized. That also like classifies. We have an imaging classifier that goes and labels. This DICOM is a T1. This DICOM sequence is a T2. This is like a T1, but also adds a tag gadolinium. So there's a piece of code that organizes the incoming data that can be fixed or modified by the user as well, or whoever uploads the data. And if also check like the protocol or checking the quality, and then it can launch the tool, and it will use what the developer defined as the input and what the was classified as what are the types of images in the image. Does that make sense?
Yeah, no, it does. No, it's very interesting, and I think that it already basically expects some of the things that will happen in the wild, and it's a good thing, because you don't want to have something.
Yeah,
then
exactly.
you have the the user that don't understand what is happening and is angry
Yeah.
because it's not running.
Yeah, and there's also like other things like to minimize like the choices, right? So like in a study, like when you invite, maybe like you created your tool and there's some data uploaded, and then you invited a clinician to run and actually like look at the images and the results. So in that study, you can also configure that project to just have available one tool and the version that you want. That's the official one. So then there's no choice even, right? Or you will just make it available that in that study, it's only to run a free surfer and your tool and that version and that version, and that's it. And then all of that can be configured behind. So then you also ensure that, with each version was all the results were calculated when, like all the aspects of traceability. So like all of that it's make things easier.
And since I don't see any raised hands, to follow up instead Chantal's points, basically, since you mentioned that you didn't have issues with like the EU or just one in the US, you wanted to add something?
Yeah, I mean, issues that
Yeah.
there are challenges, but they were solved. So like
okay.
in the sense that like we are doing things that so the issues is in describing and clarifying what are we doing about GDPR and about anonymizing. So with that, we after these kind of like checks and from the like BPO or data protection officer and other things, so that then we show how we are handling data or how is data handled with that respect, and then it's fine. So it's not issues like not a blocker.
Okay, yeah. No, because I heard from a colleague of mine in Germany that basically once had a very hard time sharing some data because even if the MRI data were defaced, the ethical committee wanted proof that basically even for him, when looking at the defacing data, he was supposed not to recognize the subjects. And now these were patients that were, there were a couple of case studies, so most probably he would have recognized those. Have you ever had very edge cases like those?
Heard or less potentially, but like there's it goes into the edge cases of like if, for instance, like if there's rare diseases and then there's just a couple of patients actually. So it's if it's about that disease, the pool of you pretty much guess that is one of those 5, So it's or if there's like location, so that's where it gets it. So it starts to enter the edge cases of like GDPR, because if the pool is like it starts to be too narrow, then there's the difficulties. Like with Germany, like in particular case of Germany, was more the it's combined, but not so much about the GDPR aspects, like about the privacy, but like the jurisdiction. So like the data from Germany would not leave the territory, right? But then with the with the ERB and GDPR, like what exactly? So actually, like another concern, so like the challenge is more like the logistics, the data transfer agreement, like what are the variables available? Are they potentially identifiable or not? And if there's something that is really needed, like age, like the age of the patient instead of a birth date, then that's converted at age as scan. There's also other guidelines, like if it's above, like people above or older than 90 years old doesn't even say what is that the exact age, but just as a pool that is above 90 years old. So like things to kind of make it less obvious that who potentially might be that person. And as you do those things, it's more of a process, like in describing and explaining that. But like that edge case, we didn't experience, like not yet. And it's troublesome sometimes, but it's more of like of the data transfer agreements and like explaining and describing all of it. But yeah, we have different consortiums in Europe, in US, clinical trials as well. So figure out many of those things.
So once again, other project leaders and of course other attendees, questions, curiosities on the presentation and what we have been saying in this last half an hour?
It's just I'm not checking my so like if anybody has further ideas or just send me an email. Yeah, Paul at Documenta or join the Slack. I'm also like in the Mattermost, so you can find us in different places. But happy to talk about something more in particular about the project or further ideas to take it further. Don't hesitate.
Okay, so if there aren't further questions, it seems not. Let's thank Paolo for the presentation. It was very interesting, and in half an hour we would have our social event, the Trivia Day Night, because here it's basically night, but in the US it's still day. And probably to make things easier, we will do it here. So we will get a 30-minute break so people can just relax a bit away from the computer, and then you can follow here the quiz. It's very easy to join. I don't need to explain it now. And the YouTube link that I shared, it will be the same. So if you want anyone else to join, or if you just want to watch from the TV and not being on Zoom, you can do it.
Thank you so much for this time and great discussion. It's very relevant topics. So very, very happy to have been here. And yeah, I'm around. Okay.
So shall we stop recording in YouTube, Matteo?
So I'll stop recording. Stop recording. Yes, but let's keep the YouTube feed on. So basically, it will remain the same link. Otherwise, it's regenerated.
Okay.
Well, then I'll say bye for the moment. Then, but I'm around if anything.
Yeah. If you want to join with your phone the quiz, please feel free to do it.
Okay, cool. All right.
Yeah, Paolo, thanks.
Bye, ciao. Thank you.
Bye.
Probably, Matteo, you can send also an email to remind about the trivia.
Yeah, well.
Many people disconnected. They are tired to be at the laptop. Maybe if you send a reminder, there will be more participants.
So I think there's a break now. Did you say at 6, right?
Yeah, so I'm sorry, I'm not going away from the display, but yes, now you are supposed to go away from the computer.
Am I allowed to go for it? Okay. I'm gonna leave, and I'll see you guys for the trivia.
Yeah.
See you later. See you later.
I'll send the email from the Cardiff mailbox because it's the safer route. Otherwise, I will end up in spam again.
Okay.
Or I will join later too, probably on the YouTube feed.
Yeah. In any case, I will keep open some ways a computer with the YouTube feed, so if people write there in the chat, I can read and comment out loud in the video.
Yeah. Okay. See you later.
See ya.
See you. So I need to leave this open, right, Matteo?
Yes.
Okay.
Yes.
So the game, you will show the questions here, right?
Yeah, and I will comment on that, and you can feel free to follow it from here or not. It's
okay. Okay. I take a break too. See you soon.
Yep.
See you.
This open.
Going to find the beers and stuff for the apero.
Yeah, that's true. That's true.
It's not a trip night without beer.
Yeah.
Come on.
In the first slide of the quiz, I have to get the most appropriate beverage for the local time.
The most
because for some places it would be inappropriate to have a spritz at this time.
Come on, here it's 7 p.m. so it's good. Good enough.
Okay, so it's 6:32 UTC, so it's almost time to start. I can see that people have connected also on YouTube. And of course, if you are from YouTube, feel free to write in the chat there as well. So if you comment, I can actually read your comments and respond to you if you want. Okay. And let's start sharing the screen for the actual trivia. So the system that we will use is called Haha Slides, and it's very simple to use. And basically, you will need just to write a simple link to access and answer the questions. You will be able to see also the questions from the screen I will share, but to answer, you need to actually write down that link. And you can also do it on the phone. It works very well on the phone. So feel free to interact as you would like. Okay. Okay, and you should be able to see my screen. So you have the link at the top, and just not to get you confused, it's up there, it's brains, but I put some numbers, so it wasn't too easy to guess the code to access. So instead of an R, you have a 7, instead of an A, you have a 4, then you have a 1, and at the end, there is a 5. And I also have opened the YouTube feed on a different computer, so I can see the comments there, and I'm looking at how much is the lag. So hopefully it will still make sense what I'm saying to people that are following on YouTube. So there are so far 4 people that put the code. We wait a bit until this number goes up. And I will basically go back and forth between these and these. It looks very similar, but actually this one is the actual trivia that we will do. And the other one is some slides that I have on the actual answers. And I hope that people won't get angry at at tricky questions. And of course, since this is an event based in Atlantis, feel free to grab the appropriate beverage for your local time. Not for everyone, it would be already time for beers, but for Europe it is. So feel free to go with that. So, and for people that are connected on Zoom, of course, feel free to use that as well. You can use that chat and I can see it. So I can see that the link is not working, so let me write it down. 7, 4, and 5. So just in case if you don't want to write that down, it's also now on the chat on Zoom. Why not? Let's write it also on the chat on YouTube. hahaslides.com. We are 8. since it looks like we are not all the people that could be, feel free to give the YouTube link around so people can actually follow this and join as well. And as soon as we are a little higher number, we can go on with the first part. Before the questions, I will do a word cloud. So if we are enough, actually, we can see where are most people and which exotic locations we reached. So for the people connected here, can you access the link for Haha slides?
Now, yes.
Okay. Yeah, please join, because I see for me I see other 12 people. So, but I don't see 12 participants yet. And I also see 10 people on YouTube. And if anyone is on Twitter, please retweet Simona's tweet on the trivia night, so more people can join. I see XD faces flying. That's a good thing. We lost a participant. So people will still have the chance for joining, but in the meantime, I will show you the next part, that is the word cloud. So at least we can start interact with things. So on either your phone or your browser, or whenever you are participating from, you should be able to see an input to actually write down where are you at the moment. Nope, sorry. Can you see it? Well, that was expected, okay. Okay. Cardiff, but Netherlands. Yes. Yeah, don't worry, there will be Italian stereotypes in the very first question, so no need to add them here. Someone is living in a desk. And Emmanuel on YouTube, I can access the link here, meaning that you can't access it. Let me know. Okay, it's getting interesting. So the living room, of course, huh? From Rennes in France. I hope that, okay, now we have Canada. That's a good thing. I was waiting. Oh, we have Mexico as well. So at least it's justified that it's called a trivia day night. Okay, good. Emmanuel can access it. No, that's good. So it's Canada. So someone is in Montreal and someone is in Canada, but Canada where? Okay, I'll take, we are 14 now. I'll take a screenshot of this. Let's see if we can manage to get it even bigger, but it looks already nice like this. Okay, so let's see what we have today. So the topics of today would be MRI quirks, human brain anatomy, animal world, microstructural paradoxes, and brain movies. We will have 3 questions for each of those, and for each question, once you have a minute, so you don't have to rush it. There's no extra point if you are fast, so you might as well try to think and guess it. And after the correct answer is revealed, basically I will show you why is that and what was wrong with the other ones. And if people join in the meantime, no worries. At any time you can join. Of course, if you miss the first question, then it will be, you will have less points because you can't get the first question points. I can see that now we are 16. Okay, so let's go to the first question. Now that I will go through the first question, you will actually be prompted to put a name and an avatar, and well, please be creative there as well. So MRI quirks. And now I will wait to see avatars and crazy names. Not too crazy. Be polite. So Viliami went, I lost Viliami. Now I see Viliami. Viliami went with the actual name, but with a very unpolite avatar. Unless that it's ice cream. So we have 8, and I can see 16 at the bottom. So I will wait for the other 8 to decide on their names. 10. I mean, you can put literally anything as a name, so don't worry about that. We are 11, but I can see 15 at the bottom, 12. The last 3, just put a random name. Just follow the auto-completing of your phone if you're from a phone. We are back to 16. 3 more people to put their names. So from YouTube, Valentina is asking, what is the prize? Let's say that it's the answer to the first question. Let's see if it's a useful hint or not. It's not a useful hint. Okay, so I think I can go on because people should still be able to guess the first one. They would just lose a bit of time. I'm about to start the quiz. Let's count to 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ah, it worked. 2 people just went there in the last 10 seconds. And let's start. So the first question is, which is the typical Italian product shown in this picture that can be non-invasively monitored with MRI during the production process? Please pay attention to all of the words in this sentence because it's a tricky one. And yeah, I didn't pick the colors, as you will see. It's something that has actually been published, so I don't know why they really liked this color map. And there is an obviously, unfortunately, wrong answer, but most people will know. And 3, 2, 1. Okay, so let's see. I guess it was too easy because 10 people realized it. I guess it was the shape, so let's see. So the Parmigiano, why it wasn't Parmigiano? Well, there isn't an actual paper on Parmigiano. There is one on Grana Padano. This is a tissue-weighted scan of Grana Padano, and they even did the tissue relaxometry of Grana Padano. The problem is that I asked for a method that could non-invasively monitor, and a whole shape of Parmigiano will never fit in a normal scanner, right? Then for the balsamic vinegar, I asked about MRI, and yeah, I'm being picky, but there are actually studies on NMR and on using the MR spectrum to characterize balsamic vinegar, although they are a bit more on classifying the kinds of vinegar rather than monitoring during the production process. And finally, it's the prosciutto. So there is this paper by Fantazzini and colleagues on meat science that basically they use MRI to actually monitor the salt and the progress of the seasoning of the prosciutto. And the first one is gone, and you already did too much, so I hope that I made all the other ones difficult enough. So let's go with the next question. Okay, hopefully this one is harder. Which one was it? Ah, yeah, this is an MRI scan of a part of a plant. Which one? So I've seen people getting angry on Reddit about this because they would say, but it's not, but it is. And it's not my fault that I put here this picture. So if you will feel angry about the result, it's actually Marco Palombo's fault. So go to him to complain.
Thank you, Matteo. Thank you.
And also in a bit, you will see a very hypnotic slide when I will go through the potential answers. And there are 10 seconds. Yeah, it's a bit tiring looking at it for a long time, right? 2, 1. Yes, it's a banana, and you would say, but it doesn't look as a banana, and that's what I said as well when I saw it the first time. So let's see. So this is actually a pomegranate. It doesn't look like that, right? This is an onion. Doesn't look like what we were looking at either. This is a corn. The sequence here is a bit weird because I don't know exactly in which direction is going. And then finally, there is the banana flower. Yeah, unfortunately, the question was about a part of a plant, and there was someone that basically decided to scan a banana flower. Well, and actually, it looks like a flower. The problem is that you will never guess that it's a banana if you don't know it. Okay, let's go to the third and last question for the MRI quirks. What did I put as a third question? Okay. Which is the intruder in this Latino American party? They are all MRI related. Yeah, so people will for sure know at least 2 of these ones, and then there are the other 2. And don't think that the one is not MRI related. That's not the correct route. And I think that people from kind of more of the technical side, if they try different things, let's say, they may get it. And actually, since this is the last question of the first section, we will actually see the leaderboard after this, and we will see how people are doing in terms of score. Okay, 3, 2, 1. Wow, no one got it. Okay, so let's see what was that. So they were all MRI related. So the first one, caipirinha, is a parallel imaging sequence. Then we have Fiesta, that is, we have here the acronym, and it's again another technique for fast imaging. Then we have Grappa, also that is quite well known for people working with MRI. And finally, we have BEAT. So BEAT is an interesting one. So if there is any MRI physicist that is familiar with that, if they know what the acronym actually stands for, it will help, because I could only find comprehensive cardiac tool, but BEAT, there's literally almost no letter of that. Anyways, so which one is the intruder? For people that put Grappa, thinking that since it's Latin American, Grappa shouldn't be there, but in South America, you also have Pisco in Peru, that it's the same procedure of Grappa, so it wasn't that one. So the actual solution is that if we look at caipirinha, it's from Siemens, and Grappa is from Siemens, BEAT is from Siemens, but Fiesta is from GE. So that was the question. Yeah, this one probably was a bit too evil, but I will make up for it in the next questions. So let's see how the leaderboard looks like. Okay, so Gani 18 and Sarah are at the top, Then we have LL, Stefan, Squirty, Ricardo, Dr. G, Emmanuel, Mario, and Lucifer. No word, and then we have other people. Oh, okay. I'm sorry you didn't get the one right. But no worries, because now things will change completely. People that had an advantage in MRI now will not have whatsoever. Well, maybe in the very first question of the next section, but let's see. So next one, human brain anatomy. Let's see what we have in human brain anatomy. The first question should be, oh yeah. Which of the following animal common names is not a part of the human brain? We have clam, seahorse, spider, and worm. Yeah, I'm quite curious to see if what people will get. Well, a couple of them may be kind of easy for people that worked with structural MRI and the structures of the brain, but the other two, well, let's see. And yes, there is a correct answer. And there will be also the vegetable one in a bit. Okay, so 3, 2, 1. Let's see. Why everyone went with spider? So let's see. Let's remember that we want the one that is not a part of the human brain, right? So, well, the worm, was it too easy? Well, the worm is the cerebellum vermis. Vermis is worm in Latin. The other one that probably also was kind of easy for people that worked with anatomy was, no, actually this one was the difficult one. So spider, and it's the arachnoid meninge, because arachne means spider. Then we have seahorse, hippocampus. This was probably the easy one. And then we have clam. What is clam? Because yeah, actually there isn't a part of the brain that means clam. And I put it there because I thought that maybe people would get tempted that would be the claustrum or something like that. And yeah, basically it worked. I'm curious to see who got it right. If the one that got it right want to say in the chat, I'm curious to know who are they. Okay, so no, sorry. So next question. And if we went to the animal world, let's now go to the vegetable world. Which of the following vegetable common names is not a human brain structure? And we have almond, marrow, olive, walnut. And well, this one should be easy, but you may never know. So how are people feeling about the question so far? Well, of course, people that are fast to reply can answer that in the chat if they want. And don't try to Google it. Also, because for some of these Googling it, it's not that simple, hopefully. Okay, so we are at 3, 2, 1. Okay. Oh, okay, good. 5 people got it then. So let's see why is that. So we have almond, marrow, olive, and walnut. So almond is literally amygdala, because it was thought that the amygdala was shaped kind of as kind of a big almond. Then we have marrow, marrow is medulla is literally marrow, the bottom part of the brainstem. Then we have olive, the olivary glands that are actually called also olives, that are part again of the brainstem. And finally, we have the walnut. And it's kind of ironic that the walnut looks like a brain, but there isn't a part of the brain that is called like a walnut. Not yet. Maybe they will discover one. Okay, so I guess that we have the last question from the human anatomy section. So let's see what is that. Oh, yeah, remember which one is that. It's a good one. Okay, so a notorious area of the motor cortex is shaped as the course of a well-known river. Which one is it? And I'm not sure if actually looking at the rivers help or not. I guess not. Also because the rivers are kind of long, and I'm asking about a notorious area, so it's a specific part. But the resemblance is it's quite there. It's not something that you say, but it doesn't look like that. No, it actually looks like it. And hopefully people won't be favored by their geographic location. Okay, so we are almost there. And 3, 2, 1, and that's it. Let's see. 4 people got it. Okay, let's see why is that. So this is the motor cortex, and the part that I'm talking about is specifically the so-called hand knob. And let's see how the actual river looks like. So this is the Nile. Doesn't look like it. Then we have the Mississippi. Doesn't look like it. Then we have the Danube, but it doesn't look like it. And now we have the Thames, that it's kind of notorious that for people that study anatomy in London, that they will be told that the part of the Thames that go around the Isle of Dogs look like the actual hand knob of the motor cortex. And I think there is also an old TV series that used this very part of the Thames River in at the very end when it would finish, but can't remember which one is it. I'm not sure that I actually watched it. It was just something that they told me. And we are at the end of the second section. So let's see how people are doing in the leaderboard. Okay. So LL was already on the top before, and it stayed there. Then Stefan went to the top, and then Sarah stayed where she was. Who is Microstructuresaurus? I don't want to know. Okay, so let's go to the next section. And the next section is animal world. This would be quite interesting. And the first one is kind on the MRI side, but just a little bit. So let's see. So the first question is, what animal has the brain shown in this picture? And it's a zebra, it's a leopard, it's a giraffe, it's a rhinoceros. There's someone that already put their answer without even thinking. 2. But the fast answers are good because then people are not trying to look up animal brains on Google, so that's good. And I'm not sure here if the shape is misleading or not. Well, you don't have something that tells you the actual scale of it, right? So it can be anything. But maybe the shape can can tell something about how the head is, what the shape of the head is. So 3, 2, 1. Let's see. I knew that people would go with the rhinoceros because it just looks huge, right? So let's see why. So here we have the 4 animals, and by the way, all the brains that I use here are from the Brain Catalog. If you don't know about it, it's an amazing resource where you can find brains and also segmentations of a large collection of animal brains. And let's see. So this is the zebra. In this case, actually, we'd overlaid the segmentation mask, and it doesn't look like it, right? Now, this is the leopard that doesn't look at all like it. And actually, it's interesting to see that it seems that leopard is less, has a less gerification than a zebra. And then we have the rhinoceros. That, well, yeah, it's kind of flat, but now that you look at the giraffe, you can see that actually, I'm not sure if it's the reason, maybe not, but that's how I explained it to me afterwards. That basically that part on top seemed to have the same shape as the head of the giraffe, but maybe it's just a self-explanation that I made for myself. Okay, so let's go with the next one in terms of animals. So the next one is this picture depicts the massive effort to count the number of neurons in an animal with a larger brain than the human one. Which animal was it? So was it a beluga whale, an elephant, a sperm whale, or a bottlenose dolphin? By the way, in these, among these 4, the largest brain is the sperm whale one, that is massive. Then we have the elephant one. Then we have the beluga whale one. And in the end, we have the bottlenose one that is slightly bigger than the human one. And also here there was a ruler on the top that could have helped, but I cut it from the picture. But actually, when you think that brains ex vivo shrink, I'm not sure it would have helped. Probably it would have been misleading. So maybe we will see it later. 3, 2, 1, and it's done. Let's see. People were really convinced that it was either a beluga whale or a bottlenose dolphin. Okay, so let's see how actually they look like. So the first thing that I have to say that I couldn't find an MRI of a sperm whale. I'm not sure if someone actually scanned it because it's large. It doesn't fit a normal scanner. And the only one I could find is of a dwarf sperm whale, but it's a smaller brain than the human one, so I don't think it counts. So let's see. This is the bottlenose dolphin one, again from the Brain Catalog, and it's amazing to see how much gerification you have in this animal. Then we have this one is the beluga whale. Again, it has this peculiar thing where they have a lot of gyri. And finally, we have it. So this is the elephant brain, and it was on a study done by Susana Herculano-Zell, a Brazilian researcher at Vanderbilt University, and it will actually come up a bit later in the quiz. And as you can see, there is a ruler on the top, but personally, when I look at the ruler and I look at the brain, if they don't tell me what brain is it, it kind of looks smaller than what I would expect from an elephant, right? But yeah, that's it. So let's go with the last question of the animal world. And we are going very, very kind of small. So in the invertebrate world, which animal has the highest brain to body mass ratio? So it's an ant, it's an octopus, it's a spider, it's a sea sponge. Invertebrate animals are an interesting thing. The problem is that we cannot actually, well, we cannot take an MRI scan of an ant, right? Neither a spider. I think that I'm not sure if there is an octopus on the brain catalog, but I don't think there is. Yeah, so unfortunately for the solution of this one, I will just show you numbers and I won't be able to show you actual brains. So let's see who will get it. So we are there and it's 3, 2, 1, and the octopus. No, it's not the octopus. No one went for the correct one. So let's see. So of course the issue here is that I talk about general animals, so I didn't mention the species, and this is this change across the specific species. But for a reference, we can also look at the same index in actually vertebrates, and we can see that we are over here. The sperm whale is over there. Huge brain, huge body. So let's see. Now, first, the sponge. The sponge was the wrong one. If you can't see it, is because I just added a very small number, because actually the sponge does not have a brain. That was something that was really disappointing, but the sea sponge doesn't have a brain. And then we have the octopus that has around 0.03. This again is for medium octopus, and here I have to say that for these animals it's hard to actually find the numbers. I spent quite a while. Then we have the spider. This is a particular spider. It's the jumping spider that has a 0.08 brain to body mass ratio. And finally, we have the ants. That one could say, but no, you are joking. It's not possible. Well, the thing with spiders and ants, and actually also with octopuses, is that basically they have neurons around their body. So basically, there are specific species of ants that have literally brain all over their bodies, and they reach the 15% of their body that it's actually brain. Okay, and that's it for the animal world. So let's see if this section actually changed the leaderboard. Let's see. Okay, so yeah, I guess it changed a bit. So I guess that the ones that were on the top at the beginning are the very MR experts, right? Okay, so we went to 3 sections. So now we can go to the 4th section, and this one would be a very good one. Let's just go for it. Microstructural paradoxes. So first question of microstructural paradoxes. Ex vivo brains can turn into a lot of unexpected materials. Which one of the following transformation has not happened yet? Into polyester, into glass, into iron, into cake. And be careful, because it's not an obvious question. Yeah, I literally can't talk without spoiling anything, so I really need to wait, because I really want to see what people answers to this, because there is one that Probably at first everyone would go with that, but I'm not sure if that's the one. 3, 2, 1, and that's it. 4 people got it, and 5 people went for the obvious one that they can't think how can it be. So let's see. So, well, the first one, polyester, is the result of plastination. This was the process that also made the brains for the bodies, the human bodies, for the Body World exhibition that has been around the world. And there is an actual method published that of plastination that works on brains, and actually made turns the brains in basically polyester. It looks like plastic, right? And then we have the good one, that is glass. So in this paper published on the New England Journal of Medicine, basically a research group in Naples reported of basically rests found near the Vesuvius, where the brain of the people turned out to glass because of the lava. That's both a bit disturbing, but also interesting to look at, that basically it's a brain and it's in glass. That would be an actual great prize, the glass brain like this, right? And finally, the one that people went for was cake. Unfortunately, I don't have a brain cake to show, but basically in some mummies in Egypt, they found that the brain of the deceased person basically turned into a cake-like material. That's literally how it's written on the publication. And the incredible thing is that basically it was soft, it was not rotten, it was intact, and it's incredible. And this is why cake is not the correct answer. I cannot show you the correct answer because it's not happened yet, and it's basically have a brain that turned into a whole piece of iron, but maybe it's something that can still happen. So let's go with the next one. These ones are all very nice. I really like them. I hope that you like it as well. So which of the following is an actual technique from neurobiology? Brain grind, brain juice, brain mix, brain soup. Yeah, also here I can talk, or I will we spoiler things to people. And yeah. Well, probably there is. I'm not sure if there is one that sounds really ridiculous, because all of them kind of sound ridiculous. But there is one that is not only for brains. Well, let's see if people get it. Actually, we also have more participants than at the beginning, but yeah, you can answer. So 3, 2, 1. Okay, 5 people got it, and 8 people were very sure that it was brain grind. So of course here now I can show you just the right answer, because the other 3 do not exist, and I couldn't find a picture of a brain juice but it would be a nice name for an energy drink, brain juice, right? So let's see. Do you remember this picture? It's this picture again. So basically, in the previous question, I asked about which brain was it, and it was regarding the massive effort to count the brain. So how they actually counted the brain? With a brain soup, meaning that basically Susanne Herculano-Hauser from Vanderbilt University studied this technique from the 70s, where they were actually able to dissolve the brain and leave just the DNA. and she actually adjusted it, and basically now they can get rid of all the materials apart from the actual nuclei, and then they can actually count the proteic nuclei, and then they have an idea of how many neurons there are. And of course, since you can't do it on a whole brain, you need to cut the brain in pieces, and then you can have an estimate of this number of neurons for each of the piece, and then you can sum it and hope that it's not over or underestimated. Yeah, cool stuff. So the last question about the microstructural paradoxes. Let's see, which one was it? Ah, yes. Which of the following pictures is not from real nervous tissue? And yeah, I think that they all look quite realistic, but there is one that, well, it's not real nervous tissue, but, and yeah, and I will tell you in a bit where these pictures are from. So if you like some of these, you can go and check out more of those later. Yeah, also here, this section was terrible because I really like the topics, but it's hard to talk about them because I will start spoiling things. So I just need to wait that the time is out, and it's out in 3, 2, 1. And okay, so 3 people got it. Let's see why is that. So let's start for my favorite, that is the first one. It's an actual picture from immunohistochemistry, and is courtesy of Jennifer Juncker, and you can follow her on Twitter at the Genji, and she published a lot of these amazing pictures of the results of immunohistochemistry, and I think they are just amazing. Some of them you would think that they are kind of drawn. She has some cerebella that are literally amazing. So if please write down a name and check them out because they are really nice. So let's go with the next one. The next one is clarity. So this one actually is an actual brain. So it's the technique where the tissue is cleared, in the sense that you get rid of most of the stuff but the protein. So basically you still have the important components there, and it becomes like transparent. And then you can combine this with the specific stainings, and then you can even identify using antibodies. And when you identify using the antibodies, this is what you end up with, and with using then microscopy on these samples. Now, between these two, which will be the real one? The real one is this one. It's the famous rainbow, basically where they were able to actually mark all the different cells with and then you are able to render them in different colors, and it looks when you have so many different cells and you put so many different colors, in the end it looks like a rainbow. So a rainbow, why not? Now this one, so this was kind of an evil question, because this is made with a technique called micro-etching, that you will work with sheets of gold, and you will be able to make surfaces that can react to the light and make very amazing things. And the reason that it looks so realistic is because the process is so thorough, and the artist put so much effort in it, that basically it actually is using real anatomical information about the connections and the kind of cells that you expect to find there. And so you end up with this that it's not a real from a real piece of brain, but actually it's hard for even people that have experience in anatomy and things like that to actually recognize that it's not. The only way to recognize that it's not true, it's a bit difficult to figure out which technique would made you able to look at the neurons like that, because it's not the same as brainbow, it's clearly different. And so unfortunately we are at the end of the microstructural paradoxes, and we are about to enter the last section. So before that, let's see how people are doing. Okay, so since we have 3 questions, each of them is for 10 points, so we don't know who actually won yet. Okay, so the last section, it's a very funny one. It's called brain movies. And I think that most people will have not seen these movies, but hopefully after this you will go and watch them. Well, probably not some of them, but few of them, yes, because I haven't watched them as well, and I really want to. You will understand which ones. Okay, so let's start with the first one. Let me say that the first one is the less funny of the 3. So if you see the first one and you don't like it, don't worry. The next 2 then will really get better. So question 13. So which of these movies is the most accurate in terms of the underlying neuroscience? Limitless, Lucy, Memento, Phenomenon. And I think I watched 3 of them, and although 2 of them I basically watched large pieces, and I think that they kind of cover the whole movie. One I watched the whole thing, and I didn't like the movie, and actually the one that I didn't like is actually what people think is the right one, but it's not. The one that I didn't watch is the oldest one, Phenomenon, that if people watched it, if people didn't watch it, it's a movie from John Travolta, very old movie. So we are almost there. So it's 3, 2, 1. And yes, people went with Memento. Good. So let's see. So Limitless is the story of someone that gets a pill and basically is very on the kind of thing, let's unlock the 100% of the whole brain, as another movie in this list, as we will see in a bit. And yeah, we know that we basically use the whole brain, but it's just that the whole brain is not just the part that thinks and do stuff and so on. And the next one, it's Lucy. This is the famous movie about the 100% brain. And I don't know if there are people that like this movie, but yeah, I think that it had a lot of flaws, and yeah, it's not the accurate one in terms of neuroscience. And then we have Phenomenon. Now we are getting closer, because here basically, because this is a kind of a sad story. So because of a tumor, John Travolta started to kind of change and kind of become smarter. But more than that, the weird part was that it was about to, it was capable of predicting the future. And it's getting closer, because basically there are cases that people that change as a result of a tumor. Of course, I never heard of people getting smarter or predicting the future, but you may never know. But the most accurate one is Memento from Christopher Nolan, that it's probably one of the most accurate depiction of amnesia done in a movie. If you didn't watch it, watch it. Very, very nice movie. And now we are entering the kind of B-movie trash part. So if anyone is a fan of that, probably will do very well in the next two. Actually, I'm not sure if people actually will have watched the movies that I will show you in a bit. So let's see, the next one. So the next one is, in which of these movies do we actually see a brain? So the first one is Creature with the Atomic Brain. The second one is Scanners. The third one is The Brain That Wouldn't Die. And the fourth one is Young Frankenstein. And I mean, 3 out of 4 are very niche movie, probably kind of B movies. But I can say that I watched The Brain That Wouldn't Die because when I think I saw on Twitter like the poster, and then I found out that it was on YouTube. So it's actually on YouTube. So if you want, you can go and watch it. And I mean, it's a crazy movie. It's you can watch it. Also, it's not long. It's like 70 minutes, something like that. It's on the very short side. So let's see how people have done here. So 3, 2, 1. No, this was too easy, because probably it's the only movie that you have seen among these ones, right? So let's see. So The Brain That Wouldn't Die, please go on YouTube and watch it. It's so funny. So despite the title, well, and despite the poster where you can actually see that brain with an eye that I just noticed now, but it doesn't appear in the movie. Basically, it's not just the brain, it's the whole head that got detached, and then this doctor managed to keep it alive, and then it tries to find another body, but the head that is still alive is kind of possessed, or in any case finds that killing another body and being alive on that body would be wrong. So the body managed, I won't tell you how it ends, but the whole point is that you don't see a brain in this movie. You just see a head. You don't see the actual brain. The next one is The Creature with the Atom Brain. Now, this is even worse because basically it's this crazy old movie, and you have these Nazis with these men that have these atomic powers, but in the end, basically it's mostly people talking the whole movie, and you don't see a brain. And the atom brain is not an actual brain. And then we have Scanners. So this is a poster in someone's office, so people may be familiar with it. And the thing is that you have these creatures that are able to make these mutants that are able to make the head of people explode. But actually, even when you look at the head explosions, that they are a bit on the gore side, you are not able to see a brain. But instead, in Young Frankenstein, you can actually see a brain. Anyone remember that Igor took the brain of AB something, and it was AB normal. It was genius. Okay, so now let's see the last question. Oops. I spoiled the question, but you didn't see the answers. Okay, so in which of these movies are brains not evil? Now, one would think, why brains should be, by any reason, evil? But I think that in the 60s/80s, people thought that if brain could get out, would be evil stuff. And also here we have really crazy stuff. And here I have a strong suggestion. It's a movie that I didn't watch, and I want to watch, and I would suggest you to watch it as well. And actually more than one, but one in particular, it just look ridiculous. And we are almost there. Let's see. So it's 3, 2, 1, and just 4 people got it. Okay, so now I will show you. So in which of these movies are brains not evil? So first one, Fan Without a Face, that are these creatures that look like brains, and actually in most of the movie you won't see them, but at the very end they are all there, and you can even see the spinal cord. And I think that this idea should be reused in some MRI related thing, because it looks amazing. And now the next one, it's I think it's an iconic one. So this is the brain from Planet Arouse. So when I saw this picture, I mean, it's amazing. Basically, you have this alien creature that is a brain that is floating around, and it looks so evil. And the next one, and you will, by knowing this one, you will know why the other one is correct, is The Brain from 1988. Well, if it, I don't know why people pictured brains to be so evil that you would have like a brain with an angry face, but that's it. And the next one, it's The Man with Two Brains. So this is not an actual horror movie, it's a comedy. And this is about this man, this scientist that finds another brain and falls in love with the brain, and it's trying to find another body for it, but not like the brain that wouldn't die. In this case, the man has an ethical problem, he doesn't want to do it. And at some point, there is a scene that is the one that I put the screenshot here, where the man basically brings the brain on a date. So here they are on the boat, and the brain is dressed as a woman and has lipstick, and yeah, I'm not sure what the director was thinking, but I think it's a movie worth seeing just for this scene, this one and the brain from Planet Arouse. And with this was the last question. So let's see who actually won. I'm about to click and we will see who won. Oops, no, I need to click here. Sorry for the suspense. So, and it seems that Stefan won. 70 points, very good. You got 7 questions out of 15, and they were kind of very random topics. So very good. You should compete in more serious pub quiz competition. So let me stop sharing. Okay, so it's 7:40, so even if we started a bit later, in any case, we managed to stay in time. I saw that people were still there, both on YouTube and on the game, so I think it went well. I hope you liked it, and let me know if you thought that the question was wrong and if you had the actual right answer, and if you had other questions that you would have liked to have. And that's it for today. Let's see you tomorrow. Tomorrow we will have the first unconference sessions with 4 talks, and then we will have more hacking time. And I hope Memento is older. I think Memento is 2015, but maybe I got the year wrong. It's quite possible. And well, thanks again, and I can't stop this, right? I think it's Marco that needs to stop it. Marco, are you still there?
Yep.
Can
Okay.